I feel immense pleasure to be here again for my course, and I am in continuation of this course. Today I am in lecture number 39, that is aircraft systems, and my topic of the day is automation in flight control and augmentation. I am Dr. Dwivedi, professor from Institute of Aeronautical Engineering, Hyderabad, India. As of now, I have completed my 4 unit. Today I am in the 5th unit and last, maybe the second last of this, all the modules. Before I commence my lecture, I have to go for a review of my previous lectures. I have started with my lecture of module 1, which consists of Introduction to Aircraft Systems. In that aircraft systems, we can divide into the 4 major components. One is the airframe systems, another is the vehicle system, third one is the avionics system, and fourth one is the mission system. So if we talk about the airframe system, we have the fuselage, we have the wings, we have horizontal stabilizer, we have vertical stabilizer, control surfaces, landing gears, engine cowlings, and these all things comes under the aircraft systems or airframe systems. Airframe system is also called the structural systems. Total mass of the aircraft is contained in this system, and all other items are accommodated. The person, the luggage, other things, all instruments are accommodated in the airframe systems, especially in the fuselage. Fuel is also accommodated. Other accessories, all the things are accommodated in airframe systems. Next, we have talked about the vehicle system. The vehicle system consists of number of systems like electrical systems, pneumatic system, hydraulic system, firefighting system, oxygen system, oil system, and so on, this thing. Next is the avionics system. In avionics system, we can divide into the 2 groups, navigation system and the communication system. Navigation systems are used for the giving the direction for the aircraft as per the requirement destination. Communication system, it is used to communicate between aircraft to the ground and ground to the aircraft, and also in different communicating centers. Third one is the mission system. Last one and the fourth one is the mission system. In the mission system, specifically is designed for the military aircraft. These mission systems may be search and rescue, maybe firefighting, or maybe some recreation or war or some training, and some other requirements comes under mission. Your search and rescue, reconnaissance, these things comes under different missions. So these military aircrafts are made to handle some missions, and for the different missions we have to use some different equipments. These equipments will try to assist during the mission requirement. Like if you are in flood relief or some cyclone, some tsunami, earthquake, these aircrafts are used for different missions, and for that mission, like ambulance mission, in that the aircraft will be made like an ambulance. In that some doctors, some nurses, some other assistants will be there, and they will also have different equipments on board the aircraft, and these equipments will run with the help of the power of the aircraft. So aircraft has to be designed as per the requirement. So these things we have covered in our unit 1, that's basics. And if you talk about the next unit or module, it is module 2. In that we have covered the electrical systems, air conditioning systems and all. power generation, power distribution, different types of power and current generation, frequency, different frequencies. These all things are covered in module 2. In module 3, we have covered the hydraulic systems and their different components which are used in hydraulic system and their function. And next we have covered in that pneumatic system, and pneumatic system is also assisting the hydraulic system. In fourth unit we have done with engine system, aircraft engines, engine control, fuel system, fuel control, different types of fuel systems for gravity fuel system, pressure fuel system, and so on. We have covered in our module 4. Now I am in the module 5. Module 5 covers the flight control system, and so many topics I have covered. Now I am the 39th lecture, and in this I am going to take about automation in flight control and augmentation. As you know, I am Dr. Dwivedi, professor from Institute of Aeronautical Engineering, Hyderabad, and my topics for the lecture is aircraft controls. It is covering the course outcomes of 6. This consists of primary, secondary, and the auxiliary. Autopilot system, it is also part of the module 5th, which is course outcomes are number 6 is covered. Sensing and correction of the control, in this also CO6 is covered. Now I will talk about the aircraft flight control system. And aircraft flight control system consists of flight control surfaces, the respective cockpit control, connecting linkage, and the necessary operating mechanism to control an aircraft direction in flight. Aircraft engine controls are also considered as a flight controls as they change speed. They can be divided into the 3 main group. One is the primary flight control, then secondary flight control, and auxiliary flight control. So these things are, I have taken this thing from the reference 3. So this is the reference. In this I have taken from the reference 3, which is given at the last of this video, last slide of this video. So now, what is the aircraft flight control system? It consists of flight control surfaces. So if you see here, I will talk about the primary flight control. So here we can see that this is the wing, this is the fuselage, these are the horizontal tail or the horizontal stabilizer, this is the vertical tail or fin or vertical stabilizer. If you see here, we have here rudder. Rudder is the primary control to have the yawing motion. Then we have the elevator here, the black color, it is elevator. This elevator is used to give the pitching motion like this, nose up and nose down. It is called the pitching. And if you apply the rudder, your nose will go left or right as per the direction of the rudder. If the rudder is moving left, your nose will go left. If your rudder is moving right, your nose will go right. And how these things are operated? These things are operated by the pilot's feet. If the pilot is pressing left or right feet, your rudder will go accordingly and nose will go accordingly. If pilot want to move towards the left, see, if your aircraft is flying like this and you want to move nose like left, so this rudder, pilot will apply the left rudder, means left pedal, which is operated by his feet. So he will press and this rudder will move like this. If it is moving like this, a lift is generated, a force is generated in this direction, and the center of gravity is here, it will try to move like that. So this is the principle of any control, especially here I am talking about the rudder control. And if you see about the next, if I want to make nose pitching up and down, this is called pitching up, this is pitching down, pitching up, pitching down, or nose up or nose down. If I want to make nose up and nose down, I need a control. That control surface name is elevator. Elevators are fixed at the tail. at the extreme tail of the aircraft, because if it is extreme tail, we need a less area because the moment arm which is generated is very long, because center of gravity is here. From here, this distance is calculated. So this falls into this distance. So this is the moment at which we'll try to make nose up or nose down. If I want to make nose down, a force should act upward in the horizontal tail. If I want to make nose up, the force should generate below this and it should go like this. So that is the elevator control. So these two are the primary, and another primary is aileron. Ailerons are always fixed at the tip of the wing. So these wings, if I want to make roll left or the right, accordingly, if I want to make roll right like this, you see aircraft is moving like this. If I want to make like this, then this wing or left wing should generate more lift and this should generate less lift or reverse lift, opposite direction. So this aileron which is going upward, the wing going upward, aileron has to go downwards like this. Initially it is like this and it is falling like this. So here lift will be more. In this side, this aileron has to go upwards. So it is like this, it will go up like this. So a force will be generated towards the earth, towards the Z direction, and it is moving like so. Here more, here less, aircraft will roll like this. So this is the function of the elevator, and these things, elevator, rudder and ailerons, these three things are the primary control of the aircraft. So this I have just depicted. This you can, now I will just now explain about this, all the three primary flight control systems. Now I will go word by word and I will explain each term very carefully. Here we have flight control systems. We have the elevator control system, aileron control system and the rudder control system. So now I will talk about the elevator control system, and this elevator. Where is this elevator? If you see here, this is the elevator. This black color at the horizontal tail or in the horizontal stabilizer. This big part is horizontal stabilizer and this black part which is shown here, it is an elevator. So I am talking about how this elevator will work and how after this nose will go up or down. That is the objective of this slide, to understand that how this elevator are working and what effect the aircraft will feel when it is flying. An elevator is mounted on the back edge of the horizontal stabilizer. The first point, an elevator is mounted on the back edge of the horizontal stabilizer. So here is the extreme back. This horizontal tails are put extreme at the tail and this is called empennage. This part which I am showing here, vertical and the horizontal stabilizer, this is called empennage. So your horizontal tail is fixed on the empennage, extreme end of the empennage. And these elevators are fixed on the horizontal stabilizer or the horizontal tail at the extreme end. This will go up or down as per the pilot's stick movement. If the pilot wants nose down, he has to push the stick like this stick, he has to put like this, nose will go down. If you want make up, he will make up like this. It will go up. If you want, it will go down. So an elevator is mounted on the back edge. So it is back edge, extreme edge of the aircraft. They move up and down. They can go upward also and the downward. If they want nose down, your elevator will go down. If this make the nose up, so it will push like this, it will go up. When the pilot pull the stick backward, the elevator go up. So this is the stick. If pilot want it is backward, it will go up. Elevator will go up, so nose will go up and vice versa. And if pilot is putting like this, nose will go down means your elevator will go down. So lift will be generated more. This lift force will pull like this. If the in this side lift is more, then it will pull like this, because motion will be from the center of gravity. So aircraft nose will go down. So if you make your elevator down, lift will be more and your aircraft will be like this. And if you want to make nose up, then pilot has to make upward like this and nose will go up. This will happen, your elevator will go also up and a force will be generated like this. It will try to pull like this. So that is the important of the elevator. This makes the wing fly at a higher angle of attack, which generates more lift and the more drag. So this elevator makes the wing fly at a higher angle of attack because it makes the more angle, so your lift will be generated and drag will also be generated more, and it will also give the pitching moment, nose up or nose down. So that is the objective of the any elevator control system. Now here I am same thing which I have explained you. Now I want to depict in this picture. This reference I have taken from the reference 3 from slide share, which is mentioned in my last, and here I have mentioned this 3 number. So here if you see, this is called empennage here. In empennage you have a horizontal stabilizer here. The green one is your elevator and red one is your rudder. This is the rudder. So if you see from the top, this your elevators are visible green, and how this will go up and down and what will happen for the aircraft. This is explained here. This is your horizontal stabilizer. This is the horizontal stabilizer and this is the elevator. So what will happen? Here is the center of gravity. I am just assuming this is the CG. So aircraft is flying. Pilot, this is the stick here. Pilot want nose down. It will press the stick from here to here. New position has come. Then what will happen? Putting down means elevator will go down. So what will happen? Flow is coming from this direction. It will reflect in this direction. A force will generate here in this additional force due to tail and elevator. So additional force is generated. This force into this moment. This is xt and the force I am writing lt. So the moment, how much will be the moment? This will be lt into xt. This moment, the direction of this thing is from anti-clockwise direction. Anti-clockwise direction or nose down direction. So it is shown here. So it is in this direction. So it is called nose down. So if you want to make elevator down, aircraft will be nose down and dive action will be there. So it is start diving like this. Next case, there is a pilot here. This is a stick. Now pilot want nose up. So what he will do? Pilot will pull like this and now new position is this one. This is the 1 and this is the 2. So means it is pushing, pulling towards its side. Then what will happen? By pulling this, the elevator will go up. Elevator go up and a force will be generated in this direction. So CG is here. So what will happen? This LT into this XT, LT into XT is equal to moment. This moment is pitching moment and direction is clockwise. Clockwise direction, your aircraft will move. So that is why it gives a clockwise and nose will go up. So this is the principle of operation of elevator, and elevators are used to make nose up or nose down, as per the requirement, and accordingly pilot will apply the stick or forward or the backward or pulling and the pushing. Now next important is ailerons. Ailerons are used for the rolling purpose. Ailerons are used for the rolling. So what is the rolling? I will just first discuss about the pitching, because I think I have left that thing. So pitching, so here is the longitudinal axis and this is the lateral axis, and the vertical is the z-axis. So this is x-axis, y-axis are the z-axis. So if the motion happened with respect to y-axis, this is your y-axis, this is black. Y-axis means this is nose up and nose down. Pitching will happen with nose up and nose down, and this will happen with respect to the lateral axis or the y-axis. So pitching will always happen with lateral axis and longitudinal axis. This is called longitudinal. Rolling will happen because in this axis, x-axis, it will not, this motion, this thing with respect to the x-axis or the longitudinal axis. So this is called the rolling. And nose up and down, it is called the pitching. So this motion is pitching, this motion is rolling. So these ailerons here, if you can see here, these are the ailerons, black color, and here is the flaps. So I am not talking about flaps now. I will talk only about the aileron. These ailerons, this side and this side. So ailerons are mounted on the trailing edge of each wing. So this trailing edge and also at the tip. Okay, and they move in opposite direction. If one is going upward, another will go downward. They are opposite in nature. They will always move in opposite direction. When the pilot move the stick left, so it is a pilot stick and it is moving left side like this. Then what will happen? The left aileron goes up. So which side the pilot is moving, that, so if I am moving left, this will go upward and this will go downwards. So what will happen? The side where it is going downwards, this will generate more lift. So here is more lift and this side is less lift. It will move like this. A raised aileron reduces the lift. So this one, they reduce the lift and this will increase the lift. Centering the stick return the, and if again I have made at the center. Initially I have changed like this. Now I made like this. Then again both will come to the neutral, maintaining the centering the stick returns the aileron to neutral, maintaining the bank angle. So, but it will maintain the same angle. The plane will continue to turn until opposite aileron motion return bank angle to 0 by stage 5. So, till the time you are maintaining a stick straight, it will bank. But if you want to again, you have to make right like this. So again it will come and it will go straight. So this is the principle of operation of ailerons on the aircraft. This I have depicted here and I have taken this thing from the reference 3. This you can see here that if I want to move left aileron down, this is the left, left aileron down, right up causes a roll to right. So this is the right side, this is the right and this is the left. So if you want right side to go down, then left aileron should go down. Aileron down here. This you can see here. Aileron up. This aileron is up and this aileron is down. So you will get the rolling like this. Right side wing is going down. And opposite will happen here. Left aileron up. So here if you see, it is aileron is up, this side aileron up, so left aileron up, right one down, causes a roll to left. So which one is up? That side, it will roll like this. Okay. So here it is down. This is down and this is up. So here a force will act like this, and here force will, and here from here to here, this is the XA. From here to here also XA. The net effect will be, because it is opposite direction, so XA LA plus XA LA is equal to total moment. So like this it will move from left to right. So the side which you want that wing should go up, that side aileron has to go down. That is the objective of this ailerons. Next, and the third one, the primary control system is the rudder control system, mounted on the back edge of the fin. Where is the rudder? This is the fin, and this you can see here, rudder. It is visible here, rudder. So this is the fin, vertical fin. It is also called the vertical fin. So mounted on the back edge of the fin. So where is the rudder? This is the rudder, and this rudder is at the back of the empennage. Edge of the fin is in the empennage, and this part is empennage, which is visible. This side is empennage. So vertical fin is in the empennage, but your rudder is mounted at the end of the vertical fin. When the pilot pushes the left pedal, so it is operated by the pilot feet. So if you operate the left one, you are pressing the left pedal, the rudder deflect left. So this rudder will move left like this. So the force will act in this direction like this, and it will move in the left direction. So pushing the right pedal causes if you make the right, then this will go right, and a force will act in this direction. So it will go right. Deflecting the rudder right pushes the tail left and causes the nose to right. So if you are pushing right, it will push towards the left. So nose will go right. Centering the rudder pedal returns the rudder to the neutral and stops the yawing. So if you want straight, both the rudder, it should be in the same way like this. But if you want the left has to be pressed. If you want the right has to be pressed. If you don't want, don't press both, you keep equal. Your aircraft will go straight, no left or right. So that is the way we have to understand the rudder control system. Here I am depicting here in this diagram, the rudder is clearly visible here. This is the vertical tail. Vertical tail. This is also called the fin. In the fin itself, at the last part of the fin, nearly 20 to 25% of the area which is movable, this part. Okay, this part is your rudder, and it can be moved by the help of the pedal and accordingly your left and right it can be achieved. Now aircraft motion and the control. So I have discussed about all these three controls, that is elevator, aileron and the rudder, and I am depicting here the motion by these three diagrams, and this all are taken from the reference number 3. So first one is the longitudinal. What is the longitudinal? This is the longitudinal x-axis, which is passing from nose to the tail. The axis which is passing from the nose to the tail is called the longitudinal axis. The axis which is passing from wingtip to the wingtip via center of gravity, that axis is called the lateral axis. And the axis which is passing vertically up and down, it is called the yaw axis. So we have the three axes: longitudinal axis, lateral axis and the vertical axis. And the motion on the longitudinal axis is a roll like this. Motion in the lateral axis or y-axis is a pitch, and motion in the z-axis or vertical axis is yaw. and how this longitudinal motion or the roll motion is stabilized. Roll motions are stabilized by the wings. The control for this roll is aileron. Pilot control, yoke, twist left or right. So there is a yoke, this you have to twist like this, like steering of your car. So left or right, it is accordingly your aileron will move. Then another is a lateral. Lateral axis, it will give the pitching motion. This pitching motion is stabilized by the horizontal stabilizer. The control for this pitching is elevator, and elevator I can show you here. Elevator are fixed at the horizontal tail, extreme end or the trailing edge of the horizontal tail. In this yoke, you have to make forward for nose down and backward for the nose up. Third one is the vertical axis. In this vertical axis, yaw motion is obtained, nose up, nose left or the nose right. It is called the yaw. Okay, so just you can see here, this is left yaw and this is the right yaw. And this happened with the vertical axis, which is passing from the top to bottom in this direction. And this control for this is your rudder, and this vertical fin is used for the stabilizing. It stabilizes the yawing motion. And the control used is the rudder pedal. It is operated by the pilot's feet like this. So here, first I will show the roll, that is the longitudinal axis. The first case here, how it is happening. This you can see the main stabilizing is your wing. This is the wing, this is the total wing here. And here we have seen here the ailerons. These are the ailerons. So these ailerons are used, and if you want to roll, one aileron will go up and another will go down. So which one is going down, that wing will go up. So that is the next is the lateral axis, means pitching. And this lateral axis, I have shown you, if the wing tip to wing tip, this axis is your lateral axis, in this pitching will happen. So here it is a pitch. Then these horizontal stabilizers are used to stabilize the aircraft. Elevators are here. This elevator will give you your pitching motion, and it is yoke forward or your backward. Third one is here. This you can see in this diagram also. This is your lateral axis, and your nose will go like either this direction and this direction, and control is here. It is called elevator. This control is used for this purpose. Third case is the vertical axis. In vertical axis, yawing will happen. Yawing means nose left or nose right. It is called the yawing. Yaw will happen in the vertical axis. Now, so I have covered this thing, and I have made a tabulated form here. So this will be very useful to understand the concept of the aircraft motion and the control, and also stability, because here stabilized by. So this stability also maintained. The wings are used for the longitudinal stability, horizontal stabilizers are used for lateral stability, and the yawing stability is achieved by the vertical stabilizer or the vertical fin, which is used in the aircraft. So till now I have covered the primary flight control system, but we also have some secondary also and some auxiliary also. So I will talk about the secondary flight control system. It is called elevator trim tab. Then another one is the rudder trim tab. These are the two trim tabs which we use as a secondary flight control system. So elevator trim tab. So if you see, here is the elevator, and here we have some small, one more part will be there. I will show here only. In the elevator, these things are available. So elevator trim balances the control force necessary to maintain the aerodynamic down force on the tail. So what is the purpose? Elevator trim balances the control force necessary to maintain the aerodynamic down force on the tail. So it is maintaining the down force on the tail. When aircraft is flying, a lot of trim could be required to maintain the desired angle of attack. So if aircraft is flying, it needs some angle of attack. That angle of attack we have to maintain, and exactly that much can be obtained by help of the trim tab. This mainly applies to slow flight, where maintaining a nose up attitude requires a lot of trim. So applies for the low speed or slow flight, there we need to use the nose up attitude. An important design parameters for aircraft is the stability of the aircraft when trimmed for a level flight. So an important design parameter of aircraft is the stability of aircraft when trimmed for level flight. Any disturbances such as gust or turbulence will be damped over a short period of time, and the aircraft will return to its level trimmed airspeed. Okay, so this is the purpose of the elevator trim tab. Here I will show here. This is your horizontal stabilizer. And this is the elevator, and if the elevator is going down, trim tab will go up. So the forces are balanced and pilot can fly without holding the stick. That is the objective. It will trim and it will maintain, and he will leave the control and aircraft will fly. So that is the purpose of the elevator. And if the elevators are, this is the purpose of the trim tab, and if the elevators are going up, trim tab will go down. So tab up, elevator down, tab down, elevator up. Both are nose down trim. It is called the nose down trim. When elevator is going down, nose will go down, but we have to make in that down position. It should fix in that angle. That time your trim tab will actuate and it will go opposite and it will maintain in the same condition. And if you want to nose up, elevator will go up, your trim tab will go down. So that is the important of trim tab. Now next one is the rudder trim system, because like your nose up and down, we need our left and right yawing also should be trimmed. Trim doesn't only apply to the elevator, as there is also trim for the rudder and the ailerons. The use of this is to counter the effect of slipstream or to counter the effect of the center of gravity being to one side. So it is also to neutralize the slipstream, and also if there is a center of gravity variation, that time trim tabs are used. This can be caused by a larger weight on one side of the aircraft comparing to the other, such as when one fuel tank has a lot more fuel in it than the other, or when there are heavier people on one side of the aircraft than the other. So in that also we have to use the rudder trim tab. Here you can see that this is the elevator trim tab here, and this is the rudder trim tab. This is the rudder and this is the rudder trim tab. So these things are used, and this is called the vertical stabilizer, and this is the horizontal stabilizer, and this is the elevator. So in elevator also we have the trim tab, and in the rudder also we have the trim tab, and this will go opposite direction. Okay, just like I have shown. Now I will talk about the auxiliary flight control system. In auxiliary flight control system, we have basically two main types of the flight control. They are called the flap control system and other the high lift devices. So flap, I can show you here. If you see here in this, these are the flaps. Flaps are mounted near the root of the wing at the trailing edge. Wing trailing edge near the root or near the fuselage. That is the flaps. So this I will be discussing in next slides. And next is the high lift devices. This also I am going to discuss. So flap control system. Flaps are hinged surface on the trailing edge of the wing of a fixed wing aircraft. As flaps are extended, the stalling speed of the aircraft is reduced. So if you extend, these are the flaps at the trailing edge. So if you move down, the stalling speed of the aircraft is reduced. Flaps are also used on the leading edge of the wing of some high-speed jet aircraft, where they may be called Kruger flap. So these flaps can also be used at the leading edge also for high-speed aircraft. Flaps increases the camber of the wing airfoil, thus raising the lift coefficient. This increases in lift coefficient allows the aircraft to generate a given amount of lift with a slower speed. So the CL increases. Also, stall speed decreases. This is the main purpose of the flaps. Extending the flaps will reduce the stalling speed of an aircraft. They also increase drag, which helps to slow the aircraft. So this is during landing, we try to increase more drag so that aircraft can be made as a slow, to runway length can be decreased. So I am talking about the flap, and this is I have taken from the reference number 3 here. Here I have shown the 4 types of the flaps: plain flap and the split flap. This is called the Fowler flap and the slotted flap. In this, the length is constant here and here. So here angle is changed, but here it is shape is same, only this part is increased. But here what happened, initially it is stuck here, as and when it is extended. So your area from here to here, this much area is increased. And here we have some slots are there. So the air will enter from here, and this makes the more efficient because it will give some energy, and separation of the flow will be reduced or delayed. So that is the purpose of this. You can also see here the air flaps, and here these are the inboard and this is the outboard flap. 2 flaps are here, inboard and outboard. And here also these are the flaps here. Here also these flaps, these are the flaps extended. Okay, so this I have taken from the reference number 3. And so flaps are used to increase the area, increase the camber, so that the lift coefficient of the aircraft is increased. Now I will talk about the high lift devices. And in this high lift devices, we have the spoiler first. So this you can see, these are the spoilers. Okay, so these are the spoilers. On low drag aircraft like sailplanes, spoilers are used to disrupt airflow over the wing and greatly increases the amount of drag. So it is deflected and drag is increased. This allows a glider pilot to lose altitude without gaining excessive airspeed. Spoilers are sometimes called the lift dampers. This is also called the lift damper because it is reducing the lift. Spoilers that can be used asymmetrically are called the spoileron and are able to affect the aircraft roll. So if left side you move more and right side is less, so it will also, your rolling will be also there and yawing will also affect the aircraft. So this you can use as a spoileron or flaperon. Same way, spoileron you can use to work as a aileron and spoiler both. Next, slats, and we can see here that also known as the leading edge devices. Slats are like a flap but at the leading edge, not at the trailing edge. Flaps are at the trailing edge. So this you can see here, flaps are here but the slats are here, and this is called the leading edge. So these slats are here. So also known as the leading edge devices. They are the extension to the front of a wing for lift augmentation and are intended to reduce the stalling speed by altering the airflow over the wing, may be fixed or retractable. Fixed slats give excellent slow speed and short takeoff and landing. So fixed slats give excellent slow speed and short takeoff and landing capabilities of the aircraft, but compromise higher speed performance. So if you want to make for high speed, it will disturb. It will reduce the performance of the aircraft. Retractable slats provide reduced stalling speed for takeoff and the landing, but are retracted for cruising speed. So retractable slats provide reduced stalling speed for takeoff and the landing, but are retracted for the cruising. So during landing and takeoff, we especially takeoff and the landing, we increase. But as and when you reach for the cruise speed at a certain, after certain time of landing and after takeoff, then we have to retract it and we have to fix inside the wing as per the requirement. This we can see here, this is the slat here, it is shown here. This slat is extended from the wing. This is the main wing and it is extracted. So if you extract, then camber of this thing is increased from here to here. Initially it was from here to here. Now the area is also increased and the camber is also increased. So CL will be increased tremendously. So it is also shown here also, and it is also shown here. All these aircrafts are operated with the slats, and here at the trailing edge we have the flap, but at the leading edge it is called the slat. So if you extend the flap and you extend the slat, a huge amount of your camber is increased. So that is the objective of any slat. Next I will talk about the autopilot. And what is the autopilot? So nowadays most of the aircrafts are using autopilot. Autopilot has made a lot of easy for the pilot, and a lot of the hard work is taken by the autopilot, and nowadays the 100% autopiloting is possible for the aircraft. So an autopilot is a mechanical, electrical and hydraulic system used to guide an aeroplane without assistance from the pilot. So autopilot will do everything by taking some feedback from the aircraft. The pilot is relieved for most of the physical mental fatigue of controlling an aircraft and is free to devote his attention to the management and direction of progress of the flight. So it is making sure that pilot is only keeping management and the direction of progress he is monitoring. Every other activities are taken over by the autopilot. On a newer aircraft today, the autopilot has evolved into a complex feature encompassing microprocessors and decision-making system which take over the complete control of an aircraft from takeoff to landing. So nowadays, by advent of the computer, these microprocessors and decision-making systems are also taken care of autopilot, and all the landing and takeoff is also possible without any problem. So these autopilots are used for this purpose. So the principle of operation of the autopilot, we can divide into the two groups of this autopilot. One is the input to system, means what input is required for the autopilot, and output from the system. We can divide into two groups. So for input, we need the pilot command. Pilot has to give some command, some input. Sensor on exterior, some sensors, your air data systems, other sensors are required. Then gyroscopes are also required. Accelerometer is also required. Altimeter, GPS and ILS, instrument landing system, global positioning system. Okay, so these are the input. From there, the autopilot will get the input and accordingly it will react. Output from the system, output will give to the servo motor where your controls will be operated. Actuators on exterior, spoilers, rudder, elevator, aileron and engines. So all these parts, output of the autopilot will go. So accordingly the engine or your aircraft will react and behave. Here I have given some layout of this autopilot, it is very essential to understand each and every topic of this system. Here we can see that we have the ultimate altitude. So it is measured by the barometric altitude. Here GPS is also there, global positioning system. From here it will find out the current position. Flight plan, this flight plan is prepared by the pilot and it is fed that from where to where, at what direction, at what altitude. Every plan will be fed on the computer by the pilot. Desired pattern you will get. Then here you will get a path planner. From path planner it will go to the desired position. Then navigation system will come into play. Navigation equipments will take over and they will behave as per the desired position. Then desired attitude, what angle of attack, at what rolling pitching, this is called the desired attitude. From here airspeed will be sensed. This current airspeed, from here stabilization will take place. This AHRS is there. This is current attitude, it will measure and then it will cue to the desired attitude and this will go to the servo. And this, according to these all parameters, by air sensors, by AHRS, by navigation, by GPS, by attitude, by the pilot flight plan, everything will be combined and will go to the computer and computer will give the input to the servos and servo will operate the control devices or the control surfaces. Accordingly, the autopilot will work. So this is the basic principle of any autopilot which has to work. Now here same thing is depicted with help of some instrumentation. So if you see here, this is your autopilot console. In this autopilot console, you have the autopilot master switch. Okay, here it will be on or off. Here we have the absolute pressure transducer. This is the knob and this is the for this. Here we have the roll servo. Here this is the roll servo. Then we have the pitch servo. Then we have VOR, GPS and other things are here. Then we have the autopilot disconnect switch, connect or disconnect here. Then if you see here, we have the turn coordinator. Then we have the directional gyro. Then we have the HSI speed indicator, or it is optional. It may there or it may not be there. So these all things which I have shown you here, these all things are sensed by these equipments. These equipments are fitted on the aircraft and accordingly your system will work. Now I will just give a simple idea about the movement of the aircraft. So this you can see x-axis here. This see here the y-axis, z-axis, and this is the y-axis. So here is the right aileron, this is the left aileron, this is the elevator and this is the rudder, and here you will have the trim tabs here. This is the trim tabs. It is not shown here. I am showing here. Okay, so these are the wings. So if you want to roll, this is in x-axis and this is also called the longitudinal axis. This is called the lateral. Y-axis is lateral axis and this is called the vertical. Okay, so if all these motions, rolling, yawing and pitching, rolling is done with respect to x-axis or the longitudinal axis, pitching is done with respect to y-y or the lateral axis, and the yawing is done with respect to the z-axis or the vertical axis. And I have previously explained about this all systems, how they are working. This is the autopilot systems manufacturer. How many companies in world they are manufacturing? The Garmin is the one company, Thales, Rockwell, Collins and Honeywell. These are the avionics companies of the aircraft, world renowned companies. These are the 4 companies which are making the autopilot for the aircraft purposes. Now I will discuss about the sensing and correction of the control. Just we have seen in Autopilot, but how these things are controlled and thus sensed. So this you can see here, it is a pitch axis, means y axis. So here it is attitude sensor. A sensor is here. This will make the error sensor. From error will give here pitch channel amplifier. Here it will go to the corrective control signal, and then it will go to the pitch servo meter and the feedback element, and it will go here and it will make your elevator up and down as per the requirement. So like this, by the aircraft is sensing and Autopilot will work accordingly. Now these are the flight director system, how the flight direction is achieved, and it is shown here that control and mode selection. It is the control and the mode selection panel. Okay, this is from the 2 is a reference. Here also this we can see on off at hold. This is Autopilot, main GS, auto APT, VR lock, HDG, off, GA. Okay, so these are the different systems which are used for the Autopilot, and they are very much essential to learn for the, especially for the pilot, to understand these things. These are the references: Moir I and Seabridge A, Aircraft Systems, Mechanical, Electrical and Avionics System, Professional Engineering Publishing Limited, London, and Bury St Edmund, UK. Second one is the Moir I and the Seabridge, same authors, Design and Development of Aircraft Systems and Introduction, AIA Education Series, AIA 2004. And this is the most of this today's lecture from this slideshare.net, Talaha Karim at Flight Control System. I have taken from this. So these are the references. Any questions, you are welcome to ask. I am available at this email, ydwivedi@gmail.com. You can ask any queries, anything in this. Thank you very much for joining this, my lecture. Hope this will be very useful for you. Please subscribe and follow this channel. Thank you very much for this.
Like, share and subscribe. Hit the bell icon for more updates.